Hello, my fellow YouTubers. This is Roy back again. I'm going to do a quick little series on the wave resonator. We covered, on the last series, we covered the Schumann. And we ended it on extremely low frequencies. On this little series, we're going to pick up, we're going to talk about overtones. And let's get into it. So over here we have string vibrates at 110 hertz. When you pluck a string, it vibrates at many different frequencies at the same time, the lowest of which is 110 hertz, fundamental frequency. So here is one point to another, the length of the wire of the string, or in this case, length of the wire of your electrical system. This is 110 hertz. This is our fundamental frequency, and this is your first harmonic, okay? One end to the other. Now this is what the string would look like at 220 hertz, and you get your first overtone. So you can see that there is a nodal point that they're saying is a overtone. And this is where the field comes up and goes in through each other and back around and up again. They swap. So this would have one nodal point, but essentially three points: a start, a finish, and a middle. 220 hertz. Then you go up to 330 hertz, and it has two overtones. So there's one nodal and second nodal. Altogether, you have 4 points. And on the third overtone is 440 hertz. You'll have 1, 2, 3, 4 nodal points, and this would be your, I drew the same one. So 1, 2, 3, 4. 1, 2, 3, 4. Yeah, so that would have 3 nodal points. That's drawn wrong, but that would be 440 hertz. And then continue on the 550 hertz would be 4 overtone, which you'll have 1, 2, 3, 4 in the middle. Your fifth overtone, you'll at 660 hertz. You'll have 1, 2, 3, 4, 5 nodes. And then this is what the wave would look like on your sixth overtone. And this is at 770 hertz. And you'd have 1, 2, 3, 4, 5, 6 nodal points, and so on. So all overtones are multiples of the fundamental frequency. So basically the fundamental frequency here is 110. All right. There's a different relationship between the length of the string and the frequency at which it vibrates. If you have half the length of your string, you double the frequency. There are many frequencies playing at once, but the overall pattern we hear repeats 110 times every second. Every time the fundamental frequency completes one full cycle, the first overtone completes 2 full cycles. The second overtone completes 3 full cycles, and so on. So the entire pattern repeats at 110 hertz, aka the fundamental frequency. And all the overtones just make the wave shape more complex. That is very important to know after I left you off on your extreme low frequencies and how your Schumann works and how the length of the distance that we're about to undertake, and so on and so on. If you want a screenshot the Overtone series, you can go ahead and screenshot that. And then you come back over here in case you want to reread it. You can screenshot that. And then that is it. That's the complete. All right, you guys. Thanks for listening. Stay tuned. I just put the primary on. I used aluminum rivets this time. Cleaner, tighter. I'm going to get these all lacquered or polyurethane so we don't have any connection between the lower and the bottom one. And they're wound opposite direction. And if you look right here, there's the end right there. There's the end right there. That one rolls this way. This one rolls this way. Pretty interesting. And we'll get into some numbers soon. I got a few more pages of videos I want to go over with you guys in regards to different fundamental parts of this whole thing. Beside frequency, beside resonance, beside the radiation that we're going to be dealing with, and how to balance this out and tune it so we can get it tuned into the Schumann. And we're dealing with a massive length on this Schumann here, because we're dealing with 24,901 miles, give or take, right? Because satellites tell us exactly around what, so that should be pretty accurate, but within close, should be close within itself. And we know that 1 mile is 5,280 feet, and you would have that number times that, and that's how many feet would be in there. And then we could know in feet how many, what's the length of wire that would be around the whole planet. Now, from what I'm bringing up here for you guys to look at, we'll explain on how we use a certain amount of length of wire and how we're going to start the process frequency, and it's going to extrapolate itself around the planet to bounce and create one line with many overtones. So the reason we brought up the overtones is because I want to show you guys some empirical data on how we plan on matching that length of wire or wave that goes around the planet. That would be the Schumann. And we'll figure out what overtone do we need to be at what frequency, so we can multiply the frequency. And one of my followers left a great comment in regards to, I believe it was 470 megahertz. So that's 470 times 1 million per second. Now I want you to think about that. That the speed of what your frequency would be at the end result here, and that is 470 megahertz. Each megahertz is 1 million strikes per second. I find it hard to believe that we have figured out how to get frequencies up. It is insane. So anyway, leave your comments. Peace out.